Okay, this video is about projectiles being shot at an angle. So before we begin, an eagle flying with an initial velocity of 12 meters per second at a height of 25 meters above the ground drops his salmon. How long was the salmon in the air? Now let's assume here that the eagle is flying horizontal and at a constant speed. So when he drops his salmon, we want to know how far down range is it going to be? Well, the time it takes to get far down range. Okay, so I'd encourage you to stop the video and see if you can get the answer on your own, and I'm going to briefly go over it in just a second. Okay, just with every single problem that we have in this class, we're going to write our knowns. In other words, what do we have out of the problem? Our unknowns, what do we want to ask in this problem? And then the equation. What equation are we going to use to connect our unknowns with our knowns? The second thing we're going to do with these word problems is we always want to put things on coordinate systems in this class. All right, so here we go. So our knowns, we've got an initial velocity, which is also the initial velocity in the x direction, to be 12 meters per second. Our initial velocity in the y direction is 0, remembering that from the last video. If I put everything on a coordinate system, I find that when the eagle drops his salmon, we're going to say at the moment that he drops the salmon, that's going to be our initial x and initial y to be 0 at the origin. So when he drops his salmon and it lands on the ground, we're going to say that our final displacement in the y is negative 25 meters. Well, our unknown is the time, and the equation that we can use to link the two is going to be this one here. Now, I'm not going to go through the algebra with this particular problem because I did so in the last video. So if you have a little problem with the algebra, I would strongly encourage you to go back to that video and watch it again, because I take you step by step on how to solve these algebraic problems. So we want to solve for time here, and what we end up getting is that time is going to be equal to the square root of negative 2y final divided by g. Plugging and chugging your values, you get a time of about 2.26 seconds. Okay, so today what we're going to do in this video is we're going to analyze projectiles with an angle this time. And we're going to do a practice problem on how to calculate information based on this initial angle projectile motion. Okay, so let's go back to our projectiles at an angle. Okay, the first thing we can say here is that at y maximum, so our trajectory is here, and the projectile goes up to a y max. When the projectile is at its maximum height, we can say that the velocity in the y direction is 0. Second thing we can say is that our projectile motion is parabolic, meaning it has a high amount of symmetry here, where one side is equal and opposite to the other side. Okay, so there are two things we can do with that. Number one, if I have an initial velocity at any given height, okay, if I can calculate that velocity at that height, if I go straight across to the trajectory at the opposite side at the same height, I've got the same magnitude of that velocity, but negative in value. We can also say that if I can calculate the time it takes to get to maximum height, I can double that to get the time it takes to get the range there. Okay, so those are two things that we can use when we're talking about symmetry in projectile motion. Okay, our initial velocity, the one given in the problem, and a hint is there's an angle with it. You're going to have to resolve that initial velocity into its x and y component parts. Your initial velocity is given at some angle theta. Resolve it using SOHCAHTOA into its x and y component parts. All right. So we've got these complementary angles here, and one thing we can say about complementary angles is that they're going to have the same range. We've got a 30-degree angle here and a 60-degree angle here. These are complementary angles, meaning they add up to give you 90 degrees. When you do so, they both are going to have exactly the same range. Second thing you can say about these complementary angles is that the 60-degree one, the higher of the two, is going to be in the air longer, but it doesn't matter in terms of range. They're going to have the same range. The maximum range of all of our angles is going to be at a 45-degree angle. So let's get an example here. Let's get this one going and finish out this video. So we got a cannon shoots a projectile with an initial velocity at 30 meters per second at an angle of 45 degrees. This angle right away tells me that I've got a velocity, which is a vector, that has to be resolved into its x and y component parts. What is the maximum height of the cannonball? Okay, here's my known, my unknown, and my equation. I'd pause the video and see if you can answer this on your own. Otherwise, go ahead and continue and let's solve it together. Okay, so our initial velocity is going to be 30 meters per second. But because it's a vector, we're going to resolve that vector into its x and y component parts. Initial velocity in the x, initial velocity in the y. We also know that g, the acceleration due to gravity, is going to be 9.8 meters per second squared. And the next thing we can say about this projectiles at an angle is that at y max, maximum height, our final velocity in the y is going to be 0. Okay, now for my unknown. What is the question asking? Well, it's asking for height, but we're going to use the variable y. We want to know what is that variable y. As far as the equation, take a look at the equations that you have in your notes and see if you can guess the one before I show you. And here it is. It is our final velocity in the y squared is equal to our initial velocity y squared minus 2 times g times delta y. And the reason why I chose this one is because we can make use of this final velocity in the y being 0. We know that, and we're trying to solve for that. So, first thing we want to do is we want to take this variable and move it over. We do not want to get rid of the 2g here because it's attached to the y here. This is the variable we're trying to solve for. We want to move everything over first and then do our multiplication and division with this guy last. So because this is added to this term here, I'm going to subtract it to both sides and clean up. Okay, before I do that though, remember our final velocity in the y down here is 0, so this disappears, and so I'm going to put this in its place. And there we go. All right, so the next thing we want to do here, I want to isolate this variable. I want this variable by itself, so I'm going to go ahead and divide both sides by negative 2g. Okay, what I do to one side, I'm going to do to the other. Now let's do that and clean up. Okay, and what I end up with is the initial velocity in the y squared divided by 2g is going to be equal to our delta y. But wait a minute, that's not the same as y, is it? Yes, it is. Because I defined my coordinate system, my initial y is at the origin, so my initial y is 0, which just gives me only my final y here. All right, plugging and chugging the values, I get a maximum height of 22.96 meters. All right, next question. Let's go ahead and calculate the time it takes the projectile to reach the maximum height. As always, I've got my knowns, my unknown, and now I've got two equations. So here we have a potential problem. So I'm going to let you try to figure it out for just a second here. Okay, so how I would figure these out, just like I always do, I'm going to put a check mark over what I know, and I'm going to put a question mark over what I don't know for each equation. And I want to methodically go through each and every equation until I get one that's the simplest. Well, I can potentially solve for this one as well. The problem with using this one here is that I'm going to have to use the quadratic formula. Take a look at this for a second. So if I take this y here, which we found in the last problem there, and move it over. So then I've got an a term, a b term, and a c term here. So you can still use it, but it's ugly. And just like most people, the quadratic formula is not a user-friendly kind of equation, so I would avoid using it, okay? But instead, check out what we have down here. I've got, this is known, this is 0 at the maximum height. We know that my initial velocity is y, we solve for that, and g, so bam, this is the equation I'm going to use, so let's get rid of that ugly other one. Okay, so we know that our final velocity in the y is 0, so I'm going to replace that with 0. And the next thing I want to do is I've got this term here, and I've got this term with my variable that I want to isolate. So I'm going to keep this guy here for just a moment and get rid of this term first. So if I go ahead and subtract both sides by my initial velocity in the y and clean up, what I do to one side, I do to the other. What I end up with is the negative initial in the y is equal to negative gt. Now, I want to go ahead and get rid of that guy there by dividing both sides by negative g. And when I do that, these two cancel, and also notice that I got a negative divided by a negative. This should make sense because you have a positive time here. Remember, time is a scalar. You can never have a negative scalar. So what we can do here is we can get rid of the negatives by dividing a negative by a negative, giving me the initial velocity in the y divided by g is going to give us a positive scalar time. Plugging and chugging my values, I get 2.16 seconds for my time. So let's go ahead and add that to our knowns and try another question. Calculate the range of the projectile. So here's all my information. And from there, I want to know, well, what is going to be my delta x, or my range in this problem? Okay, with this particular problem, remember, in the x direction, there is no acceleration. Because there's no acceleration, this is the only equation you need for every projectile motion problem, assuming there's no wind resistance. And in this class, we're going to do that. There is no wind resistance, so this is our equation. We're going to use it every single time in the x direction. Plugging and chugging. All right, so we get 45.9 meters. Okay, so let's review this real quick and see if you can get a practice problem done here on your own. What we want to do is we want to resolve the initial velocity into its x and y components. Then we want to use the fact that at y max, the velocity in the y is going to be 0. And if that's the case, we can have only two equations that we can work with here. We've got the final velocity y squared is equal to the initial velocity y squared minus 2g delta y, or final velocity y is equal to initial velocity y minus gt. For both of these, we can go ahead and get rid of this term here because it's 0. So we're going to use this first one to find the maximum height. We can use the second one to find the time it takes to reach the maximum height. Then, once we find our values here, we're going to have a problem that's going to tell us to find the range. In this case, we can use the time we found up here, and we're going to double it. Then use delta x equals initial velocity in the y times t. All right, give this one a shot here. So a golf ball is hit on a level fairway. If the golf ball is hit with an initial velocity of 27 meters per second at an angle of 12 degrees to the horizontal, how high did it go? Now, I'm not going to go through any of the problems. I'm just going to give you the answer because I did that earlier. Go ahead and pause it, take your time, and see if you can get the same answer as me. All right, did you get 1.61 meters? If so, good job. If not, go back and watch the video a little bit or come in for some help here. All right, how long did it take the ball to reach maximum height? Pause the video. Okay, I'm getting at about 0.57 seconds. And finally, how far did that ball travel? Pause the video. Okay, going to be about 30.24 meters. Okay, so hopefully you did well. These problems can seem a little complicated at first, but just like everything else, if you follow my instructions, if you do it step by step by step, you'll be fine every single time. Thank you for watching.